All right. Today we're looking at 4.8 inferences and experiments. And these will be the notes for this. In looking at this, we're looking at when you run a well-designed experiment, how can you tell if the outcome is from chance or if it's from a change affected by the treatment? So, the easiest way for us to think about checking this is when we run a simulation many times, how likely would it be to get your actual result compared to all of the other results? Let's put a little context into this. So a student takes a 20-question multiple choice test in which there are 4 answers for each question. The student gets 8 questions correct. How would we determine if the student guessed and got lucky or knew some of the answers without guessing? Now, in statistics, we use a number that we would call, or a term called, statistical significance. In this, the results of the experiment is unlikely to happen by pure chance. We generally use 5%, and we also call that the alpha level, right? We say alpha level 0.05. There will be times when you'll see different alpha levels, maybe 0.01. However, for the most part, we're referring to 5%. If the alpha level, or the probability of the event occurring, the cumulative probability, is less than that 5%, say it's probability 3.2, we have convincing evidence that the treatment, or whatever we're doing, caused that difference, that it's not by pure chance. So going back to the question earlier, and we asked, okay, what if a student got an 8? Would we assume this was by pure chance? So I would take the value where 8 is, and I would sum all the subsequent values up to it. When I do so, I would get a value of 10.2. Well, so the student has 10.2 chance of guessing and getting an 8 or more correct. Obviously, 10.2 is not less than 5%, meaning that 8 is not statistically significant and could possibly be attributed to chance. Of course, meaning we're not assuming that they guessed. Okay. What about if the student got 10 of 20? Well, let's go back and check. We can see this 10 of 20 is occurring at 0.99 plus the additional values. There's about a 4.1% chance, right? Now, 4.1 obviously is less than that 5%, meaning it is statistically significant. And it is not due to chance. And not due to chance. Therefore, right? Therefore, we can assume they were not just guessing. Now again, if I sort of look at it visually, I make some sort of guess, and then I look where my data point is. If it's above the threshold, right? If it's the top 5%, or maybe the bottom 5%, it's telling us that this is a significant event. Okay. Next, I want us to move not into the class activity, but directly into the homework for this lesson 4.8.